Hello everybody, this is teacher Jason from Think Academy Singapore, and today we're going to be going through our NMOS daily math doses. So basically, within the week, we're going to be sending several questions inside the group chat to give you some chance to have a practice for your NMOS examination. Now, before we start off the questions here, at the start of the day, we would like to send you a short video so that you can understand some key concepts coming from this topic. And today, we're going to be tackling angles calculation. So some of the table of contents for today, we're going to be going through our interior and exterior angles, followed by your special triangles, and lastly, your angles inside a polygon. And at the end of the video, we're going to be having a short practice question coming from the NMOS book. So I do hope that you have already collected your NMOS book. Now, for interior and exterior angle, we can actually look at the typical triangle that we have here. Our typical triangle consists of our angles inside called the interior angles. We call it A, we call it B, and we call it C. And within this triangle, actually outside of this triangle, we also have your exterior angles as well. Basically, the angles outside of the triangles, but also touching it. And you can see an example over here, we have D. But I'd like to give you an important formula. An important formula would be A plus B equals to D. Wait a minute, how do we actually get these angles to be the same? So let me show you a short proof. Now, we have angle A plus angle B plus angle C that we know it is 180 degrees. And at the same time, we also do know that if we add up angle C plus angle D, it also gives us 180 degrees because it is angles on a straight line. Now, if we do know that both of them are equals to 180 degrees, we do know as well that angle A plus B plus C equals to angle C plus angle D. And since both sides of the equation has your angle C, we can do some cancellation, giving us angle A plus angle B equals to angle D. So basically, a method to go and do your exterior angles calculation. Now, the next part, we have our special triangles, our isosceles and equilateral triangles. Now, the left side being the isosceles, the right side being the equilateral triangle. The main thing to focus for your angles calculation is that for isosceles triangles, both sides, okay, the legs are of the same length, and for the equilateral triangle, all three sides have the same length. Now, furthermore, for the isosceles triangle, the base angles of the triangles are identical, while for the equilateral triangle, all three sides are of the same angle. So we can actually see equilateral triangle, very easy to determine. All three sides are 60 degrees. The next part is your angles inside a polygon. Your polygon over here refers to basically a shape with many sides. And we have a few formulas for you to take note. The sum of angles inside a regular polygon is actually n minus 2 times 180, where n refers to the number of sides. So as we can see here, our octagon, the octagon with 8 sides will have a total angle of 8 minus 2, 6 times 180 degrees, giving us 1080 degrees. But how can I do a short proof of this? This octagon, I can actually cut it into multiple triangles. So let's see. If I draw a straight line across like this, and like this, and like this, and so on and so forth. A couple more triangles to draw, and we have one more. And how many triangles do I have here? 1, 2, 3, 4, 5, 6. And that's where your 6 multiplied by 180 came from. Now, in order to find just one of these angles inside, okay, because it's what we call a regular polygon, all 8 sides will have the same angles. So all we need to do is just to divide by 8. Okay, and this is one of the other formulas we need to know as well. Okay, so let us take a look at our NMOS book, and we can turn to page 57. So in the diagram below, ABC is a triangle. AD and BC are perpendicular, while BE and AC are perpendicular as well. Point F is on BE such that your angle BAF equals to DAF. We can already mark out these two angles to be the same angle. Let's call it X. Now, they also mentioned that AF is the same length as BF and that ABE is 25 degrees. We want to find the angle ACB. Now, this question may be a special round question, but I'll tell you, once we use some of the topics, the concepts we have learned from earlier on, it gets much easier. Because we already noticed that ABF is actually an isosceles triangle. ABF is isosceles. So this means that we can already determine one of these angles. This angle X over here would have been 25, since the base angles of your isosceles triangles are identical. This is 25 degrees. And we also know that DAF is the same at 25 degrees as well. So why not we also change this X to 25 degrees, as mentioned inside the question itself. Now, the question is actually asking us for this angle ACB. It may seem very far away from the other angles inside the figure, but there is a special quadrilateral. Do we see this quadrilateral over here? Okay, let me just mark it out generally. This quadrilateral here. This quadrilateral, we have three angles that we kind of know. We have your 90 degrees, another 90 degrees, and also the angle that we are determining. If we can just find out one of the other angles given over here, we can actually solve this question. So why not we do some markings and try to see whether we can find that single angle. Oh, wait, that angle, where did the angle come from? So we can actually see this angle can be determined from the angle just vertically opposite to it. Let's call this, in this case, A, B, C, D, E, F. We don't have a G, we use the letter G. Let's try to go and find the angle AGB. AGB, inside your triangle ABG, we can actually take 180 degrees minus 25 times 3, considering we have 3 of the 25 degrees, giving us 105 degrees. And your vertically opposite angles will give you, in this case, DGE to be 105 degrees. Since we know this is 105 degrees as well, we can find our angle ACB very quickly. ACB would therefore be 360 degrees minus 90 degrees. Sorry, give me a moment. Let me make a minor amendment. 90 degrees times 2 and minus the 105. Once we calculate all these values out, we know that the final answer is 75 degrees. And just like that, a special round question becomes very easy for everybody. So at the end of the day, please take note as well. After this video, please make sure to go do the following. Number 1, please complete the 3 questions that are being sent out inside the group chat. Please remember to send your answers inside the group chat as well, so that we can mark it for you. And last but not least, please take note of the solutions that will be sent out inside the group chat. And that's all for today's video. So see you, everybody.